Hello everyone, this is Dr. O.P. Verma. Today we will discuss arithmetic progression and its applications. So to discuss the arithmetic progression, we need some term like sequence and series. So first we will discuss the sequence. So what is a sequence? It is a set of numbers which are written in some particular order. For example, take the number 1, 3, 5, 7, 9 and so on. Here we seem to have a rule. We have a sequence of odd numbers. To put this another way, we start the number 1, which is an odd number, and then each successive number is obtained by adding 2 to give the next odd number. Here is the another sequence, that is 1, 4, 9, 16, 25 and so on. This is the sequence of squares of numbers like 1, 2, 3, 4, 5, and this is another example. Sequence is 1 minus 1, 1 minus 1, 1 minus 1 and so on. So is a sequence. This is a sequence of numbers alternating between 1 and minus 1. In each case, the dot written at the end indicates that we must consider sequence as an infinite sequence, so that it goes on forever. So on the other hand, we can also have finite sequences. The numbers 1, 3, 5, 9 form a finite sequence consisting only just 4 members. The numbers 1, 4, 9, 16 also form a finite sequence, and so do these the numbers 1, 2, 3, 4, 5, 6 dot dot n. These are the numbers we use for counting, and we have included n of them. Here the dot indicates that we have not written all the numbers down explicitly. The n after the dot tells us that this is a finite sequence and that the last number is n. Here is a sequence that you may recognize like 1, 1, 2, 3, 5, 8 and so on. This is an infinite sequence where each term from the third term onwards is obtained by adding the two previous terms. This is called Fibonacci series sequence. We often use an algebraic notation for sequences. We might call the first term in a sequence u1, second term u2 and so on. With this same notation, we would write un to represent the nth term in the sequence. So u1, u2, u3 dot dot un would represent a finite sequence consisting n terms. As another example, we could use this notation to represent the rule for the Fibonacci series. We would write un equal to un minus 1 plus un minus 2 to say that each term by the sum of two preceding terms. Next definition is series. A series is something we obtain from a sequence by adding all the terms together. For example, suppose we have the sequences like u1, u2, u3 dot dot un. The series we obtained from this is u1 plus u2 plus u3 plus u4 plus dot 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 so on plus un, and we write Sn for the sum of these n terms. So although idea for a sequence and a series are related, there is an important distinction between them. For example, let us consider the sequence of numbers 1, 2, 3, 4, 5, 6, so dot 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 n. Then S1 equal to 1, as it is the sum of just the first term on its own. The sum of first two terms is S2 equal to 1 plus 2, that is 2, 3. Counting we get S3 equal to 1 plus 2 plus 3, that is 6. S4 equal to 1 plus 2 plus 3 plus 4 equal to 10 and so on. So arithmetic progression. Consider these two common sequences 1, 3, 5, 7 dot 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 and 0, 10, 20, 30, 40 and so on. It is easy to see how these sequences are formed. They each start with a particular first term, and then to get the successive terms we just add a fixed value to the previous term. In the first sequence we add 2 to get the next term, and in the second sequence be at 10. So the difference between consecutive term in each sequence is a constant. That is, in first is 2 and second is 10. So B could also subtract a constant instead, because that is just the same as adding a negative constant. For example, in the sequence 8, 5, 3, -1, -4 and so on. The difference between consecutive term is -3. Any sequence with this property is called an arithmetic progression, or AP for short. We can use algebraic notation to represent a arithmetic progression. We shall let A stand for the first term and of the sequence and let D stand for the common difference between successive terms. For example, our first sequence could be written as, that is 1, 3, 5, 7, 9 and so on. So first term will be written as 1, 3, second term 1 plus 2, third term, that is 5, can be written as 1 plus 2 into 2, so fourth term 1 plus 3 into 2, and for next term 1 plus 4 into 2 and so on. And this can be written as a plus d, a plus 2d, a plus 3d, a plus 4d and so on, where a equal to 1 is the first term, d is the common difference. If we wanted to write down the nth term, we would have an equal to a plus n minus 1 into d, because to write nth term we will multiply the common difference by n minus 1, because in the first term we did not multiply, we did not add the common difference. In second term we only add the common difference one time. In third term we add the common difference two times. In fourth term we add the common difference three times and so on. So in the nth term we add the common difference n minus 1 time, because if there are n terms in the sequence, there must be n minus common difference between successive terms, so that we must add n or on n minus 1 to the starting value. We also sometimes write L for the last term of the finite sequence, and so in this case we would have L equal to a plus n minus 1 into d. So how to find the sum of an arithmetic series? Sometimes we want to add the terms of a sequence. What would we get if we wanted to add the first n terms of a arithmetic progression? We would get Sn equal to, Sn is the sum of n term, a plus d plus a plus 2d plus a plus 3d plus l minus 2d plus l minus d plus l. L is the last term. So now this is now a series, as we have added together n terms of the sequence. This is an arithmetic series. We can find its sum by using a trick. Let's write the series down again, but this time we shall write it down with the terms in reverse order. We get Sn equal to L minus t plus L minus 2d plus L minus 3d dot so on plus a plus 2d plus a plus t plus a. So here we are now going to add these two series together. On the left hand side we just get 2 into Sn, but on the right side we are going to add the terms in the two series, so that each term in the first series will be added to the term vertically below. In the in the second series we get 2 into Sn equal to a plus l, a plus l, a plus l, a plus l plus a plus l n times. On the and on right hand side there are n copies of a plus l, so we get 2 Sn equal to n a plus l, but of course we want Sn rather than 2 into Sn, so we divide it by 2 to get Sn equal to 1 by 2 n into a plus l. We have found the sum of an arithmetic progression in terms of its first term and last term, a and l, and the numbers of terms n. We can also find an expression for the sum in the terms of a, n and common difference d. To do this, we just substitute the formula for L into our formula for Sn from L equal to a plus n minus 1 into d, Sn equal to 1 by 2 n a plus L. So here we will substitute the value of L. So Sn will be 1 by 2 n sorry, so value will be Sn equal to 1 by 2 n plus a, and value of L is a plus n minus 1 into d, n minus 1 into d. So this is the formula for a sum of n terms of AEP in terms of nth term, first term, and common difference d. So this formula is written here. On simplification, we will get this is a plus a. It will give you 2a. So we will get the formula for sum of n terms. So here is the example. Find the sum of first 50 terms of the sequence. So you have to find the sum of first 50 terms of this sequence. So this is an arithmetic progression. As you can see, we can write down here first term is 1, common difference is 2, and last term n term is 50. So we have the formula to get the n sum of n term of AP Sn equal to 1 by 2 into n, 2 plus n minus 1 into d. So we have all the values, substitute the value of n, a, and d, we will get the sum of first 50 terms. So here n is 50, so 1 by 2 into 50 into 2 into a, 2 into 1 plus n minus 1 into common difference d. So on solving this, we will get 2500. That is the 2500 is the sum of first 50 terms of the given sequence. Here is another example. Find the sum of the series, that is 1 plus 3.5 plus 6 plus 8.5 plus dot 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 plus 101. So last term is 101. So here we have to find out the sum of this series. So this is an arithmetic series because the difference between the terms is a constant value 2.5. We also know that the first term is 1 and the last term is 101, but we do not know how many terms are in the series. So we will need to use the formula for the last term of an arithmetic progression. So L equal to a plus n minus 1 into d. So to give us here L is 101, first term is 1, number of terms n we have to find out, and d is 2.5. So on solving this, now this is just an equation for n. The number of terms in the series, we can solve it. If we subtract 1 from each side, we get 100 equal to n minus 1 plus 2 into 5. And then dividing both sides by 2.5, it will give you 40 equal to n minus 1, or you can directly solve. So that, so n will be 41. So there is a 101 is the last term is 41th term. Now we can use the formula for the sum of an arithmetic progression in the version using L to give us. So Sn equal to 1 by 2 n a plus L. So n is 41. So so this will give you 1 by 2 into 41 plus 1 plus 101. So here last term is given, so we will use formula in terms of last term. So on solving this, we will get the sum 2091. Here is another example. An arithmetic progression has 3 as its first term, that means a equal to 3. Also sum of first 8 term, that means S8, is twice the sum of its first 5 term, that means S5. So S8 is twice its S5. Find the common difference. That means you have to find out the D. So solution, we are given that a equal to 3. We are also giving some information about the S8 and S5, and we want to find the common difference. So we shall use the formula Sn equal to 1 by 2 n in bracket 2a plus n minus 1 into d. For the sum of first n terms, this tells us that S8, that means sum of first 8 term, 1 by 2 into n plus n is 8, 2 into a, that is 6 plus n minus 1 into d, that n is 8. So 8 minus 1, that is 7. And S5 equal to 1 by 2, here n is 5. So 1 by 2 into 5 plus 2a, that is 2 into 3, plus n minus 1, that is 5 minus 1, 4D. So using the given fact that S8 equal to 2 into S5, so we see that we will put here the value of S8 and S5. So we will here have a equation in D. So on simplification we will have 8D equal to 6, that means D equal to 3 by 4. So the common difference is 3 by 4. So here is another example based on the AP. In a flower bed, there are 23 rose plants in the first row, 21 in the second row, 19 in the third row, and so on. There are 5 rose plants in the last row. How many rows are there in a flower bed? So solution is given. The number of rose plants in the first, second, third, and dot 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 rows are 23, 19. So 23, 21, 19, dot dot dot, and 5. So it form an AP. Let the number of rows in the flower bed be n. So why it's AP? As you can see that each term is obtained by subtracting 2 from the first term. So 23 minus 2 you will get 21. After get again subtracting 2 from 21 you will get 19, and so on. So here this is in AP. Let n term is n, last term is n, or sorry, suppose that the number of term be n. So here a equal to 23, that means first term is 23. Common difference is 21 minus 23, that is minus 2, and the last term an is 5. So we have the formula for the nth term. An equal to a plus n minus 1 into d. So an is 5, that means last term is 5. So a is 23 plus n minus 1 into d minus 2. So on solving we will get this value minus 18 equal to n minus 1 minus 2. So on solving this we will get n equal to 10. So there are 10 rows in the flower bed. So here is another example. A sum of 1000 is invested at the 8% simple interest per year. Calculate the interest at the end of the each year. Do these interests form an AP? If so, find the interest at the end of the 30 year making use of this fact. So solution is given. We know that the formula to calculate the simple interest, that is given by simplest interest equal to P into R into 2 divided by 100. That P principal amount, R is the rate, and T is the time. So the interest at the end of the first year is principal amount is 1000, rate is 8%, and time is 1 year, divided by 100, so that will be 80. Similarly, the interest at the end of the second year, so that is given by the same formula. Here T will be 2, time will be 2 years, so this will be 160. So interest at the end of third year will be the same. Here T will be 3, so it will be 240. Similarly, we can obtain the interest at the end of the fourth year, fifth year, sixth year, and so on. So the interest at the end of the first, second, third, and dot dot years respectively is given by 80, 160, 240, dot dot dot, and so on. So it is an AP as the difference between the constituent term in the list is 80. So here first term is 18 and common difference is also 80. So to find the interest at the end of the 30 year, we have to find A30, that means 30th term. So an equal to, we know that the formula an equal to a plus n minus 1 into d. So A30 equal to a plus 30 minus 1 into d. So we have the value of a as 80, n is given 30, so 30 minus 1 that is 29 into d, that is 80. So we will have the value A30 equal to 2400. So the interest at the end of the 30 years will be 2400. So this is the exercise for you. First question, a sequence given by the general term, and you have to write down first 5 term of the sequence. And second, a sequence given by this formula, write down the first 4 term of the sequence, and you have to also find the what will be the 10th term. Find third question, find the sum of 23rd term of AP. AP is given this. Fourth question, find the sum of arithmetic series whose with first term is 1, common difference, and last term 100. So last term is given, common difference is given, and first term is given. So you have to find the sum of the series. Fifth question, sum of the first 20 terms of a term series is identical to the sum of the first 22 terms. If the common difference is minus 2, find the first term. These are some references from where we have taken the material to prepare this lecture. Thank you everyone.